Okay, so quite a few people requested some explanation on, it was mostly the last two, so number 5 and 6. And also people expressed some confusion on parts D, E, and F. So I'll be paying specific attention to those parts as I go through them. So just a reminder, the question was about a particle moving according to some rule S equals f of t, and then there's 6 different possibilities for f of t. They want you to find the velocity as a function of time, which is just the first derivative. They want you to find the velocity after 3 seconds. They want you to find when the particle's at rest. They want you to find when it's moving in the positive direction. They want you to find the total distance traveled in the first 8 seconds, and they want a little motion diagram. So let's go through number 5 first. So number 5, our rule or our function is f of t equals t over t squared plus 1. Okay. So in part A, we want to know what the velocity is. So the velocity is just going to be the first derivative. Now, in order to calculate the first derivative, we're going to have to apply the quotient rule. So we'll kind of call this maybe our F or our G and call this our H. And remember the quotient rule, you do the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, all over the denominator squared. So we'll go through and do that. So V of t is going to equal, derivative of numerator is just 1 times t squared plus 1, so that's going to be t squared plus 1 minus the numerator, which is just t, times the derivative of the denominator. So derivative of the denominator is going to be 2t, and then the 1 just kind of disappears. It's going to be 2t times t, so minus 2t squared, all over the denominator squared, so that's t squared plus 1 all squared. We can clean this up a little bit. So we have t squared here, and we have minus 2t squared here, and we just have this 1. You can write it either way. A lot of times people like to write the positive thing first so that you don't have a negative sign hanging on the outside, but 1 minus t squared, or you could do negative t squared plus 1, all over t squared plus 1 squared. Okay, so that's your answer for part A. This is the velocity versus time function. Part B, they want to know what the velocity is after 3 seconds. So this is just v of 3. So we'll plug 3 in. So we do 1 minus 3 squared. Okay, so that's going to be negative 8. Okay, over, and we'll do 3 squared, which is 9, plus 1 is 10, squared, which is 100. So negative 8 over 100, or if you prefer, negative 2 over 25, or if you want it as a decimal, negative 0.08 feet per second. Okay. Any of these answers is acceptable, either the fraction or the decimal. So, and the units are going to be feet per second for speed or velocity. Part C, they want to know when the particle is at rest. So we're going to set our velocity equation equal to 0. So we'll do 1 minus t squared all over t squared plus 1 squared equals 0. We can just multiply both sides by t squared plus 1 squared. When we multiply this over into the other side, this is going to equal 0, okay? So we just get 1 minus t squared equals 0. Or t squared equals 1. There's 2 possibilities for t squared equals 1. Either t is negative 1 or it's positive 1. But because we're looking for values for time, the only answer that actually makes sense for our purposes is t equals 1 second. Okay, so when t equals 1 second, our velocity of the particle is 0, or the particle is at rest. Okay. Part D, they want to know when is the particle moving in a positive direction. So basically, when is v of t positive? So we can look at both the numerator and the denominator to kind of deduce when it's going to be positive. So looking maybe first at the denominator, because everything in the denominator is squared, the denominator is always going to be positive. So whether the velocity is positive or negative depends essentially entirely on the sign of the numerator. So if we look at the numerator, we have 1 minus t squared. So basically, whenever t squared is less than 1, this is going to be positive. If t squared equals 1, it's going to be 0, as we kind of saw here. And if t squared is greater than 1, the numerator is going to be negative, so the whole thing is going to be negative. So we kind of see here when t equals 1 second, remember our velocity is 0. So when t is between 0 and 1 second, including 0 seconds but not including 1 second, we're going to have positive velocities. That's our answer to D. E, so part E is kind of the trickiest part for all of these. So we want to know the total distance traveled during the first 8 seconds. It's a little bit easier actually in this one because there's only 2 windows really that we need to consider. We need to consider the first second, okay, because our velocity is going to be positive in that window. And then we need to consider the window from 1 second to 8 seconds, so that 7-second window, because our velocity is going to be negative there. So when the velocity is negative, we're kind of moving backwards. When the velocity is positive, we're moving forward. So we kind of break the total distance into those forward moving and backward moving chunks. So the distance is going to be equal to the absolute value, just in case we start at a position further forward than the position that we wind up. We still want to count that as positive distance. It's going to be the absolute value of f. So we're not looking at our velocity function. We're looking at f, which is our position function. F of 1 minus f of 0. Okay, so this is the distance that's covered during that first second of motion when we're moving in the positive direction, plus the absolute value of f of 8, so this is our position after 8 seconds, minus f of 1, so that's our position at 1 second. And this here represents the distance traveled in the interval when we're moving backwards, okay? So moving forward, moving backward. Okay, so all that remains is to actually, do these calculations. So at 1 second, let's see. So we plug 1 in for t. So we have 1 over 1 squared, which is 1 plus 1, so that's 1/2. Okay, so the distance is equal to the absolute value of 1/2 minus, now f of 0 is, if we plug 0 in, it's pretty clear that this whole thing is 0, okay? Plus, now f of 8, okay? F of 8 is going to be, we plug 8 in here, so we have 8 over 8 squared is 64, plus 1 is 65. So this is the absolute value of 8/65, okay, minus, we already saw here that f of 1 is 1/2. So it's 8/65 minus 1/2. Okay. So we can see pretty clearly here that 1/2 minus 0 is going to be positive. So we can just take that out of the absolute value brackets. And we have 1/2. Plus, now the difference here, 8/65 is pretty clearly less than 1/2. So 8/65 minus 1/2 is going to be negative. In order to take this out of the absolute value brackets, we're going to have to flip it. So we'll have 1/2 minus 8/65. Okay, so plus 1/2 minus 8/65. Okay, 1/2 plus 1/2 is 1. Okay, so it's 1 minus 8/65. Okay, and 1 you could rewrite as 65/65. 65 minus 8, okay, is going to be 57. So 57/65 of a foot. Okay, not not a terribly useful fraction like that, but it's about, you could write it as a decimal, 0.88 feet. Okay, so pretty close to a foot, but not quite. So in that whole 8 seconds, whatever particle this is doesn't even move an entire foot in total distance. And finally, in part F, if we want to take a look at a motion diagram, we just want to draw a little axis here with S, our position. So remember, in this one, we start at position 0. So we can put a little dot here and say this is at 0 seconds. And then for the first second, we move forward. Maybe we'll go by 1/8 of a foot. So here's an 1/8, here's a 1/4, okay, here's 3/8, and here's a 1/2. There's maybe 5/8, 3/4, whatever. So for that first second, we go all the way up to 1/2 of a foot. Okay, so there we are at 1 second. Oops, 1 second. Okay, and then we turn around. Okay, remember at 1 second, that's when our velocity turns around and becomes negative. So our position is going to be going down. And we're at 8/65, which is just a little bit over an 1/8. Okay, so we can put a little dot here. And this is our position at 8 seconds. Okay, and then we're going to keep going. Okay, this is when we sort of turn around and the particle just keeps moving backward. So this whole distance here that we drew, this length here, is going to be equal to that 57/65 or 0.88 feet. Okay, so this is our motion diagram, and that is problem number 5. I'll post problem number 6 in a little bit.